In software engineering, we are taking chapter number 12, Design Concepts. The design model. The design model, first of all, there can be two views. We can view this in two different dimensions. From the requirement model, we make the design model. So, the analysis model is created when we are doing the requirement engineering. Then we translate it into the design model. So, as I said, two dimension can be thought. In the Cartesian coordinate system, we have x and y axis. Similarly, here we have the x axis as the process dimension. And then the y axis, here we have the abstraction dimension. This process dimension is indicating the evolution of this design model as design tasks are executed as a part of the software process. I am discussing about the software development life cycle. How in this process this design model proceeds. Then we have the abstraction dimension. So this is representing the level of detail as each element of the analysis model that has been developed in the requirement engineering is transformed into the design equivalent. And then it is refined again and again. So you are refining it iteratively. So if you see here, there is a dashed line in between. This dashed line is actually a boundary between the analysis model and the design model. The upper part belongs to requirement engineering. The lower part is design model or design part, software design part. So design model, it uses various analysis model, that is the analysis model UML diagrams. And in design model, these UML diagrams of the analysis models are more refined. They are more elaborated. They are given more substance as a part of design. So architectural design, first of all, it sets the stage. It starts everything. Followed by the interface design, the user interface, etc. And the component level design. Finally, the deployment level design. So this deployment model, this will be delayed until we design all other things. In between, wherever you want, you can put the design patterns. These design patterns can be applied at any point during the design. So this is the design model. Now let us see this figure once more. Now in the analysis model, we have created various UML diagrams or various model. For example, to make the architecture, from where you are going to get the inputs. Actually, you are translating the requirement model into the design model. So exactly same thing is happening here. If you want to develop the architectural elements or architecture elements in the design, you have to take the input from the class diagram, analysis package, CRC, collaboration diagram, DFD, control flow diagrams and the processing narratives. And then you do the refinements. So this refinement is actually whatever you have got from requirement engineering, this refinement is you are making in the architectural element. I hope you got the idea. In the interface elements also, you made use case diagram, activity, swim lane, collaboration, state, sequence diagrams. So how do you translate it? How do you actually give information so that it can directly be coded? This is the interface element. For example, GUI design you do here. Navigation design, the technical interface design. Then coming to the component level. Class, CRC model, collaboration diagram, all these you have made. But here you are refining it, the component diagrams, design classes, activity diagram, sequence diagram, you are refining it. Then finally, when you are actually going to put it somewhere, that is install it somewhere, port it, then you have constrained interoperability, targets and configuration. So you make the deployment diagrams. Data is the most important part of any kind of design. So data design is also called as data architecting. Now, if you have 23, you can represent it like this, you can represent it like this. So there are so many data structures and the functions which are going to help you or allow you to handle or process this data. So data design is all about creating a model of data and information represented at high level of abstraction. What I'm trying to suggest here is the data design is all about how the user or a customer view the data, not the programmer. This is the data design. So you make an architecture of data also. So architecture of the data is the key, because actual architecture of the software is totally dependent on how do you make the architecture of the data. Data is the numbers, data is the values, data is the information, data is the input, data is the output. So at program component level, the design of this data structure and the algorithms, for example, you're using stack or the linked list or the structure. So the data structure and the algorithms, or you can see the functions of the program to manipulate them. And when you are able to do that, that can create a high quality application. This is the program component level. On the application level, because you have already got from requirement engineering the data model. So you are converting or translating this data model into database. And this is very important because database is the most integral part of any kind of application level or the business objective to be achieved. At business level, collection of information stored in the different disparate database, and they are reorganized, because if you are dealing or making a data warehouses, then only the data mining or knowledge discovery can be done. So this is at the business level. This is how we do the data design. These are the different parts. These are the different levels. Architectural design. So architectural design is the way a floor plan of a house is developed, or you can say an office layout is developed. For example, you have different floor. How many floors are there? How many rooms will be there? 2 BHK, 3 BHK. This will be the floor plan of a house. So we are not going into the detail here. So floor plan, for example, in general life, it shows the overall layout of the rooms. What will be the size? It is 10 by 10, 12 by 12. What will be the shape? What will be the relationship between these two or different rooms? It can be like this. It can be like this. There can be different views, different size, different shape. And what are the relationship? Do we have the bathroom in front of your sitting room, or it is at the last? How do you go inside and come outside? You need to have a window or the doors. So that will allow movement into and out of the rooms. This is also the part of the architectural design. So as the floor plan gives us the overall view of the house, of any say building or of any office layout, similarly the architectural design element is the overall view of the software. I hope you will be able to relate it. So architectural model is derived from certain sources, mainly 3 sources. From where do you get? From the information about application domain for software to be built. What does it mean? See, are you building your house? Are you building, say, your office? Or you're making house, say, for some religious purpose? For example, the Ambani's house will be different from a normal, say, a middle ordered or middle income person. This is the application domain. So information about application domain for software to be built, this is the source for architecture model. Then specific requirement models like use case, the analysis classes. How are you going to use this floor plan Are you going to use it as your house, as your say gym? What are the relationship? What are the collaboration between different rooms with different parts or different say the areas of that layout? This is the specific requirement model element like the use case and analysis classes and also their relationship. This is the input for the architectural model. And whatever is there, if it can be used, that is the architectural styles and patterns. For example, in your bathroom, the sink, all rooms will have, all bathrooms in every floor will have this sink. So this can be a pattern or an architectural style. So architectural design element is depicted, is represented as a set of interconnected subsystems derived from the analysis packages within the requirement model. So again I am saying the content are coming from requirement model and we are in design model trying to refine it, trying to give more information. Okay. For example, in Ambani's house, there will be a security room in front. You won't have it for a normal house. So this is coming from requirement model because the requirement is different. Interface design elements. So now you are going into more detail. So interface design for any software application is analogous to detailed drawing or the specification about the doors, about the windows, and what are the external utilities of a house. Is the store outside? What about the parking? So how the interfacing is done between different parts, what is the actual specification? So it tells us how things and information flow into and outside the house and within the rooms. So the interface design elements, as I said, it is representing or it is showing the flow of data inside and outside of the system, along with how it is communicated among the different components in the architecture. So three very important elements of this interface design will be the user interface, because the user is going to interact. If you want to enter a house, you need to have a main gate. If you want to enter any room, it has to have a gate. So the user interface is the first point where the user is going to interact with the software. The external interfaces to other system, devices, networks and other producers and consumers of the information. That is how this software is related with network. So you need to have an interface between them. For example, if this is a kitchen or a bathroom, you ought to have an exhaust fan. So this is also kind of interfacing. So this can be an external interface. The internal interfaces between various design components. So now we are talking about one component, but there are different rooms. One is a storeroom, one is a kitchen. How they are having the interface so that one can finally identify this is this thing, and how to go and come outside that. So interface design elements, these interface design elements, they allow the software to communicate externally and enable the internal communication and collaboration among the components. So usability design, also we know it as user interface design. It encompasses what? Aesthetic elements. What is the layout? What is the color? Is the color good for eyes? Graphics, more graphics, less graphics, interaction mechanism. You are using joystick or keyboard or voice recognition. Ergonomic means it is helpful for the human body to work on. That is, generally people are right-handed, so you don't want to give everything on the left hand. So information layout, placement, metaphors, UI, navigation. Technical elements, that is those components or patterns which are already there. How to use it, where to use it, and what to use it if it is there. For example, e-commerce, if you are using, payment gateway is already there, so it can be used. It is the technical element. So design of external interfaces requires definitive information about the entity to which information is sent or received. Okay. An interface is actually modeled in the same way we model a class. In unified modeling language, an interface, let us define it first. What is an interface? An interface is a specifier for the externally visible operation of a class, component, or other classifier. It includes the subsystems also, without specification of internal structure. That is, you are saying these are the plug-in points. This is what you see for a class, component, or any other. These are the plug-in points. I am not going to tell you the internal structure. So an interface is like this. Okay. I'll give you a very easy definition of interface. Interface is a set of operations that describe some part of the behavior of a class and provide access to these operations. So if you have a class, here we are discussing the interface. What are the interface? How to link it? Let me give you an example. For example, there is a security system, safe home. So safe home security function uses the control panel. User has a control panel, a keypad. He enters, he sees various things, and this may be implemented via a mobile platform also, like the smartphone or a tablet. Now, how to extend or how to use the interface for smartphone and tablet? Because the control panel, this is a class. So this provides behavior associated with the keypad. Therefore, it must implement the operation read keystroke and decode key. What I am trying to say, that if the user is using the keypad, it is desired that we need to have read keystroke and decode key, because it is all about key. Okay. But what about tablet and smartphone? They have to do the same thing, but in their way, in their own way. See, the control panel class has already read key, stroke and decode key. But when you are talking about keypad or a tablet or a smartphone, these two functions has to be there and they have to be implemented in their own way if these operations are to be provided to other class. It is useful to define an interface. So the interface, here you see a keypad is there. So it is shown properly as an interface, and it has a, it can be shown like this. It can even be shown by a small labeled circle connected to the class with a line. So this is a bubble. You can show like that also. So I am suggesting that keypad is already there. So it has to implement these two functions. And for tablet and smartphone, they also have to have it and implement it in their own way. So interface is defined with no attributes and set of operations that is necessary to achieve the behavior of a keypad. Keypad will decide it. Keypad will do it. Same thing is for tablet and smartphone. No attributes and set of operation. Now it is to them what they have to do. I hope you got the idea. This is the interface. So dashed line with an open triangle which you see in the keypad, it indicates the control panel class provides keypad operation as a part of its behavior. If you have to have a control panel, there is a behavior called read key, stroke and decode key that you need to implement. For interface, it is giving that this is this there, but you have to implement while actually doing it. When you are doing with keypad, same is that with the tablet and the smartphone or any other device. See, in UML, this is called as realization. Okay. That is the part of the behavior of control panel. Who is going to implement it? The keypad operations. Who is going to implement it? The tablet operation. Who is going to implement it? The smartphone operation. Right? So these operations will be provided to other classes that is going to access the interface. Interface will show if you want to use control panel, you have to implement these functions. So those who want to access control panel, they have to implement it. Component level design elements. So component level design is actually equivalent to the set of detailed drawing or specification of each room in the house we discussed about the plan layout. That is, now you are coming to the actual room, and you are talking about what is the wiring detail, plumbing detail, how many electric holders will be there, the wall switches, the stoppers, the sinks, the showers, the tubs, the drains, cabinet, closets and whatnot. So all the details, this tub, one tub is a component, cabinet is a component, shower are the component, stopper is a component. So component level design describe the full internal detail of each software component. So component level design, it defines the data structure for all the local data objects, for example drains, and algorithm detail for processing within a component, an interface that allow us to access the component behavior, that is the function. For example, this is a component called as sensor management. So how it is represented? You see these are two blocks. On the left hand side it is being given, showing that this is a component. There is a dashed arrow also. So this is connecting component to a class. What is the name of the class? Sensor. So the class name sensor is assigned to this sensor management component. So this sensor management component will do all the function associated with the sensor. It can be any sensor. Deployment level design elements. Deployment is now you are actually installing it, deploying it, porting it. So deployment level design element indicate how software functionality and the subsystem of the system will be allocated within the physical computing environment. For instance, again the example of safe home product. These are configured to operate within three primary computing environments. What can be these computing environments? It can be your home-based PC, the PC you work or the laptop you work. There will be a safe home control panel. And there will be a server, which is the company's server. For example, the company name is CPI Corporation. It will also give you the access to from the remote site. So three computing environments are shown here, but there will be more. We are not showing it. It can include the sensor, cameras, and even if you are using it in the mobile web platforms. So the subsystems of the functionality, they are housed within each computing element. These are indicated here. So I'll just show you how this control panel will have security. The CPI server will have access right. The PC will have external access, security, observation, management, communication. So all these are shown as a kind of directory. Okay, a kind of directory. But these are actually the part of these deployment. I'll give an example of that. For instance, say a personal computer, it has subsystem that implements one of them does the security part, one of them surveillance, home management, communication feature, right? Now the external access subsystem which you see here, this has been designed to manage all attempts to access the safe home system from any external source, okay, from the control panel, from the CPI server, or even from the mobile platform. So we will start with the descriptor form. This deployment diagram in the descriptor form shows computing environment but not explicitly indicate the configuration details. We don't give the configuration detail here. For example, the personal computer is not further identified. Why? Because it can be a Mac, it can be Windows based PC, it can be Linux, it can be mobile platform, it can have an Android. So it can have its own operating system. So these details are provided when deployment diagram is again revisited in instance form. There will be another form, instance form, during the latter or the later stage of the design, or even the construction phase when it starts. I hope you got the idea. Okay. So this is all about this discussion. Thank you so much. Take care of yourself.